Okay, so we have a particle of mass m constrained to live between x equals 0 and x equals L. And let's say that its wave function is 2 over root L sine of 3 pi x over L e to the minus I e3t over h bar. So it's in an eigenstate with a fixed energy. Let's find how the probability density depends on time. Let's look at the time dependence of the probability density. First of all, let's specify this E3 value just for practice. Given the fixed boundary conditions, we know that this function has to vanish here and here, so it has to be a sine because the sine of 0 goes to 0, and the sine of KL also has to be 0, and so we know that K times L has to be n pi, right? So n equals 1, 2, 3, and so on. This function vanishes. So the energies come from this boundary condition. So this tells us that K is equal to n pi over L, but the energy here is kinetic, so it's p squared over 2m, which in terms of K is h bar squared k squared over 2m. And so we have h bar squared over 2m times this squared, which is n squared pi squared over L squared. Of course, there's a pi in here, so we probably should simplify this. If we specify the pi's, then we should write this as h squared over pi squared, which cancels that, over 2m L squared. H bar is h over 2 pi, so we get a 4 here, and therefore this becomes an 8. So we have an 8 there. So those are the energy levels, and so we have a particle with a fixed energy equal to 9h squared over 8m L squared, and we want to find the time dependence of the probability density. Well, right, this is psi star psi, which is 2 over L sine, right, this is the real part, that stays as is, but here we get e to the I, e3t over h bar, that's psi star, and now we multiply that by psi, e to the minus I, e3t over h bar, which is 2 over L sine squared of 3 pi x over L. So notice that the probability density doesn't depend on time. And the key here is that absence of time dependence, right? So there's no dynamics here. That is intimately related to the fact that there's one specific energy. So that if we want dynamics, we need different values of energy.